Here we go, lesson 2, Introduction to Set Theory, part 2. So we talked about sets and stuff yesterday, and elements and all that good stuff. So we're going to use that today just to build off it a little bit more. So use the following information to answer the following questions. So we have 4 sets of information here, okay? The first thing is a universal set, which are natural numbers from 1 to 40 inclusive. So natural numbers, if you go back to the first page of your notes so far, the natural numbers don't include 0. So we're basically going 1, 2, 3, all the way up to 40. So that's our universal set. That's everything. Set E is going to be the multiples of 8. So let's think about the multiples of 8. We've got 8, 16, 24, 32, and 40. Then we've got set F, which is the multiples of 4. So we've got 4, 8, 12, 16, 20, 24, 28, 32, 36, and 40. And then we've got set S, which is multiples of 17. So we've got 17 and 34. We're going to try and display all this information in this Venn diagram. So let's think about 17 and 34 to begin with. I don't see 17 and 34 anywhere in the other 2 sets. All right, so 17 and 34 are going to be in set S over here, kind of by themselves. They're included in the universal set, but they're by themselves. Now, set E and set F. Now, set E is a part of set F, right? Anytime you see something in set E, it's also included in set F. So we can kind of kill 2 birds with 1 stone here. If we put set E inside of set F, so 8, 16, 24, 32, and 40. And then we call this set F. So set F, we need to add 4, 12, 20, 28, and 36. But because set E, the circle, is inside of the circle F, that means that F also includes the elements of E. Now there's some numbers that are not in any of these in E, F, or S. So let's just start with them. We've got the number 1, 2, 3. 4 is inside set F. 5 isn't anywhere else. 6 isn't anywhere. 7, 8 is inside E. 9, 10, 11, 12 is included. 13, 14, 15, 16 is in set F. 17 is in set S. So then we've got 18, 19, 20 is included in set F, but 21, 22 I don't see anywhere, 23, 24 is, 25, 26, nope, 26 is nowhere, 26, 27, 28 is, 29 isn't, 30, is 30 in there? Nope. 30, 31, 32 is, 33, 34 is in set S, 35, 36 is included in set F, but 37 is not, 38, and 39, and 40 is in set E and set F. All right, so we've got all our numbers. Took a little bit, but let's go through each statement, true or false. Okay, E is E. Let's think about E. Is E a subset of F? Yes, it is. So that's true. Okay. Is F a subset of E? No, that's false. It's the other way around. Is E a subset of E? Yep. Okay. Is 12 not an element of E. So think about E. Do we see 12 inside that circle? No, we do not. So this is a true statement because this is saying this is not a little slash. In this example, the set of natural numbers from 41 to 50 is not part of it. Contains no elements. Also true. So we move on to the complement of a set. Now, complement of set A is the set of all elements in the universal set that are not in set A. The complement of set A is denoted by A with an apostrophe. So consider the following two sets. So A is the natural numbers less than 20 that are divisible by 3, and B is the natural numbers less than 20 that are divisible by 5. So the universal set is going to be equal to the natural numbers less than 20. I probably shouldn't use the number symbol. I should probably actually use, okay, because we're using words, not symbols. So let's list the elements of the following sets given the information above. So set A, less than 20 that are divisible by 3. So 3, 6, 9, 12, 15, 18. Set B is divisible by 5. So 5, 10, and 15. Now we don't include 20 because it's less than 20. It's not less than or equal to. And set A, or the complement of A, is going to be anything that's in the universal set that's not in A. So 1, 2, and then 3 is in set A. 4, 5, 7, 8, 10, 11, 13, 14, 16, 17, and 19. Okay. Again, we don't include 20 because it's not, it's less than 20. It's not less than or equal to. So let's display the relationship between sets A and B using a Venn diagram. So set A and B, anything common between the two? 15. So 15 goes in there. So 5 and 10 are going to be part of set B. And set A is going to be 3, 6, 9, 12, and 18. Okay? And then anything that's not in those is going to be part of the universal set. So 1 and 2, I don't need a comma there. 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. Okay. Write a description of the elements of the complement of set B. Complement of set B. So B with an apostrophe are natural numbers less than 20 which are not divisible by 5. You can usually get away with saying not something to describe a complement. So set C, we're going to do a little subset here. So set C is a natural numbers less than 20 that are multiples of 6. So let's figure this out. List all the elements of C. So C is equal to 6, 12, and 18. 6, 12, and 18. And that will be set C. They're included in set A. It's a subset. List the elements of the complement of C. So C prime is 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, 13, 14, 15, 16, 17, and 19. So that's anything that's not in C. So we're going to add set C to the Venn diagram above, which we did. State whether the following are true or false. Is C a subset of A? Yeah, that's true. Is C not a subset of B? Also true. Is C prime a subset of A prime? False. Okay. 15 is in C prime, but not A prime. Disjoint sets, they're disjoint if they have nothing in common. All right, so if we have these two sets, set C and set D, they have nothing in common. They're part of the universal set, but they're not in common. Okay. All right, so we have a summary of notation introduced so far. Sets are denoted using uppercase letters, and the elements of the set are defined within curly brackets. So the universal set is a set of natural numbers less than 10. So we've got 1, 2, 3, 4, 5, 6, 7, 8, and 9. And then we've got set A, has the numbers 1, 2, and 3 in it, which are going to be 1, 2, and 3. All elements of A are also elements of U, so A is a subset of U. So we can write A is a subset of U. Okay. The set A prime is a complement of A. It can be defined as A prime is equal to anything that's not in A but was in the universal set. So we've got 4, 5, 6, 7, 8, and 9. Now to define the number of elements within a set, number of elements in the universal set is 9. In A there's 3 numbers, and in A prime there's 6 numbers. Okay. Last page on this notes. Okay. Given the universal set U from the last page, we've got, let's do it in set builder notation. So B is equal to X such that it's between 6 and 10, and X is an element of the natural number system. So let's display U, A, and B using a Venn diagram. So A is 1, 2, 3, B is 7, 8, and 9, and in the universal set, we also have 4, 5, and 6. So sets A and B are described as disjoint because they have no elements in common. And state whether the following statements are true or false. So I would pause the video, go through it, try and figure it out, and then come back and check. So is 1 an element of A? That's true. Is 2 an element of A? False. It's an element, sorry, not a set, because this describes a set. So it's not a set. All right, is B an element of B? False. B is a set, not an element. Okay. Is B a subset of B? That's true. Is 4 not an element of B? So there's set B. It's true. It's not an element of it. Is A not a subset of B? That's true. Is B a subset of A? False. B is not a subset. Okay. Is there no elements that are a subset of A? True. A is an element of U. That's false. A is not an element. A is a subset of U. That's true. Is B a subset of the complement of A? Interesting. Yes, it's true. And A complement a subset of A. That's false. The elements of A prime are not in set A. List all the subset in set A that are have the elements 1 and 2. So we've got that. We've got 1, 2, and 1 and 2. Okay, so the subsets are nothing, 1, 2, and also both of them, 1 and 2. So subsets are basically how can you split this up? Okay, well, you could have nothing. You could have 1, you could have 2, or 1 and 2. Those are all the different ways. So those are all the different subsets.